Hey, I'm Roshan Ryan, and this is my EECS 280 application. All right, so today we're going to be talking about function overriding in derived classes. All right, so let's start out with some context for the code I have on my screen right now. So we have a class game, we have a class football that derives from game, and both of these have score functions. In a game, you can just say you all score whenever you score, right? And in football, you don't just yell score, you say touchdown. All right, so in our main method, what do we have? We create a game object, and then we basically convert this to a pointer here. And then this line, we just take that game pointer, dereference it, and invoke the score function. So what do we expect this to do? Well, it's just a game function, and we're calling the score function, right? Sorry, it's a game object, and we're just calling the score function. Well, it should just go in here and run this function. It should just print score, right? As you can see down here, just print score. So exactly what we expect, right? Now let's say we're dealing with a football object. So let's change this. All right. So now we have a football object, right? And we're converting this to a game pointer. And this is allowed because game is a base class of football. So what do we kind of expect to happen here? Well, game pointer points to a football object, and we're just invoking the score function on that. So we expect it to just run the score function and print touchdown. Let's see what happens. It's still printing score. So before we get into why that's happening, let's talk about some what dynamic and static binding are. So static binding basically means that whenever you're referencing an object, it's referencing the base class. Versus with dynamic binding, it means it's referencing like whatever class you're dealing with. So in this context, we have a football class, right? So the static binding references the base class, which in this case is game, right? In dynamic binding, it just references whatever class it actually is, which is just a football, right? All right. So when we call the score function, a game pointer really references like a game, right? So when we call the score function, is actually using static binding. And we said static binding means it's referencing the game class, right? So this is actually going to the game class, and we have this function score, right? And it just sees this is the function I'm supposed to run, just see out score, and it prints score, right? What we want to happen is we want it to actually print touchdown. So what does this mean? We have to use a dynamic binding. How can we tell the compiler we want to use this dynamic binding? Well, we do this using the virtual keyword. So the virtual keyword basically means I can be overridden. What does that mean? A derived class can basically define a function that's the same as me, has the same function signature, but it can do something different. So this virtual keyword means, hey, if you're calling me from a derived class instance, look for a function signature that matches me in that instance, right? So it says look in the dynamic binding that's in the class football. And this void score has the same function signature as this. So invoke this, and it should just print touchdown. And that's exactly what happens. Right. Now let's talk about a common bug, right? So if you have a very large code base with a bunch of different derived classes, right? You could have slightly differing function signatures because that's like a very easy bug to make. So let's say this is actually a const function, right? Well, the function signature here consists of like void score const. That's the whole thing. So when we have the virtual keyword here, that basically says if you call score, look for a matching score function void score const in the derived class if you're calling me from derived class, right? So we have the score function, look in a dynamic binding context, and we look in here. There's no actual function that matches this void score const. We only have void score. So it actually still just should print score. And if we run, We can see that's exactly what happens. So how can we minimize these errors, right? Well, there's actually a way we can do that. And it's by using the override keyword. So basically, when we put the override keyword here, we're basically telling the compiler, hey, this is supposed to be overriding some function in the base class. So it basically looks for a function in the base class with the signature void score. Well, this comes from game, and game does not actually have a void score. It only has a void score const, right? So this error is basically telling us, hey, I'm actually not overriding something. You need to fix this. So now we notice, hey, these signatures don't actually match. Let's make them match. So now these have the same function signatures. They're both void score const. And now we invoke score. It's a virtual function. So it says, look in a dynamic binding context. So we look in dynamic binding context, which is here. We have a matching definition, function signature. So call this instead. So this should just print touchdown. And that's exactly what it does. Right, so this was just a really quick introduction to overriding functions and a bit on static and dynamic binding too.